What happens when you bring the best of open source telco networks and take it to the enterprise edge? Well, it's the latest iteration of Linux Foundation Networking's 5G Super Blueprint. We're seeing a transformation in networking away from the confines of the telecommunications environment. Capabilities like private 5G are taking networks and putting it in the hands of enterprises. And those same enterprises, with initiatives like Industry 4.0, have to be more agile and more automated. Combining edge computing with an open, responsive, and secure network will bring benefits to the entire ecosystem. This latest demonstration of the 5G Super Blueprint shows that exact combination, a full private 5G network with edge computing. Our scenario is an industrial company that's trying to ensure its workers' safety. Video feeds are sent from cameras over 5G to AI models running at the edge doing video analysis to ensure that workers in dangerous locations are wearing the right safety equipment. As the chair of the Technical Advisory Council for LFN, I'm thrilled to see how the community has stepped up to show the art of the possible with next generation networks. The demonstration includes projects from LF Edge's Open Horizon and Secure Device Onboard, as well as the open source Free 5GC. Thank you so much to the companies that have contributed their time and efforts, including Caluum, Red Hat, NVIDIA, GXC, Lenovo, IBM, and Arna Networks. I hope you'll take a look at the 5G Super Blueprint, and we welcome your contributions to the Blueprint or any LFN or LF Edge project.
Hello, good morning. My name is Ganesh Venkatraman from Caluum. This year for the Linux Foundation One Summit at Seattle, we are working on a 5G end-to-end use case scenario with our partners within the Linux Foundation community. And we will share the lab architecture at Caluum, where we have physically installed the different components and configured without using any simulator. The use case we are demonstrating is ultra reliability low latency communication, URLLC with hard hat detection, and enhanced mobile broadband EMBB with YouTube streaming from our Caluum lab. The overall architecture of our end-to-end system, we work with multi-partner ecosystem to provide low latency at the edge. Our Caluum Fabric, UPF and slicing, it is a cloud-native solution which integrates with Red Hat OpenShift to deliver single execution platform. The GXC provides the RU, CU and DU with the 5G UE gateway. The core component is the Free 5GC, and IBM provides the edge application use case for hard hat detection, which has two components. One is the training server and the other one is the edge server. So GXC system is installed in the Faraday cage, the 5G standalone that combines the RU, CU and DU, and it's an end-to-end system which runs on 5G NR waveform. So let's go in. So here is where we have the 5G RAN from GXC, we have the phone here connected, and then we have the 5G UE gateway at the end. So the RAN has two slices. The first slice we do EMBB with this phone, where we do the demonstration of a video running on this separately, and then the second slice is the URLLC, which comes from the camera all the way connected to the RAN, which goes to the fabric on the other data center and also to the UPF and the IBM software. So let's go now and then check on the GXC server. So this is where the GXC server, which has the CU, DU installed in it, and there are four cables here on the fiber. This is the first one which is connected to the Faraday cage. This one goes to the clock, and these two are the ones which goes connected through the patch panel to the other data center on the other side of the road. Hey, this is the rack with LFN Caluum 5G Super Blueprint rack, where we have the switches here, we have the Caluum fabric here, the UPF which is connected, then we have the Free 5GC core in one of these servers. We have these two servers identified for IBM. One is the training server, the other one is the edge server. The models are trained in the training server, and it is being deployed via an API to the edge server, which is closer to the data. This lab is permanent and will be used for customer proof of concept and demo. Our goal is to have quarterly webinars within the ecosystem and all partners to expand on our use case with Industry 4.0, healthcare, and enterprise customers, and as well as targeting CSPs and TSPs. We welcome any new partners to join to be part of the solution. If needed, please contact the Linux Foundation for any logistics. Finally, I want to thank all the partners and the Linux Foundation team who had worked tirelessly to bring this project to a reality. Thank you very much.
Hello, this is Sani. I lead business development and marketing for Kaloom. I'd like to take this opportunity to thank LFN and all the partners for their participation in this exciting project. I especially want to recognize everyone's effort in making this end-to-end edge solution demonstrating monetizable applications a reality. Kaloom has worked very closely with the Linux Foundation communities and ecosystem partners for years in demonstrating the values of open source based multi-vendor environments and the value we deliver together to the market. Our active participation has been and will continue to be based on our strong belief that it takes a village to deliver the entire solution. That specifically rings true as the technologies and solutions proof of value being demonstrated here are new, and the customers are looking for assurance like this to adopt and benefit from the emerging technologies. Thanks again, and looking forward to continued collaboration in delivering value of our technologies and combined solutions and helping customers accelerate their innovative services delivery to the market. Thanks again.
Hello, my name is Satish Saragopan, and I'm an executive architect and associate partner at IBM Telecom Center of Excellence. I represent IBM at the LFN 5G Super Blueprint work group. We have defined a 5G reference architecture with open source and multi-vendor ecosystem of products. I've been working with Kaloom, GenXCom, MITRE, and a few other members in setting up the 5G network in Kaloom's lab in Montreal. IBM is implementing our 5G Edge use case with IBM Maximo Visual Insights for low latency processing of high density video feeds. Right, IBM Maximo Visual Inspection is a video and image analysis platform that offers built-in deep learning models that learn to analyze images and video streams for image classification and object detection. In Kaloom, we have our Maximo Visual Insights installed on two servers, the training server and the edge server. The models are trained in the training server that provides the tools and accelerators to develop and train deep learning models for video and image analysis. The trained models are then deployed on the Edge server via IBM's Edge Application Manager that is based on open source standards such as Open Horizon and Secure Device Onboard. The Edge server is closer to the data source and analyzes the input data stream for anomalies and raises awareness for appropriate action. An extension of this use case in the next phase, the solution will be deployed on IBM Cloud Satellite at the Kaloom Labs to demonstrate a distributed hybrid cloud and 5G MEC use cases. I'm looking forward to collaborating with Kaloom and other members of the 5G Super Blueprint group for a long-term evolution of this open source based 5G architecture and use cases. Thank you.
Hello, my name is Hardik Jain. I'm one of the co-founder and CTO at GXC. GXC is a US-based 5G O-RAN solution provider. We are headquartered in Austin, Texas. We're providing O-RAN solutions to our customers and partners. We're excited to be participating with Linux Foundation and the ecosystem partners coming together with this 5G Super Blueprint project that we are demonstrating today. Our contribution to the project is a 5G Open RAN system, which includes a radio unit, a centralized unit, CU, and a distributed unit, DU. We have several devices that are connected to our 5G O-RAN system as a part of this demo. Cameras, phones that are demonstrating slicing functionalities like eMBB, URLLC, massive IoT. And as you will see in the demo, we demonstrate these capabilities for edge applications. We're also connecting consumer devices onto the 5G standalone network.